Welcome you all for today's experiment, calibration of ammeter and voltmeter. Aim to calibrate the given ammeter and voltmeter using a potentiometer. Principle: the potential drop across a segment of a wire of uniform cross section carrying a constant current is directly proportional to its length. Apparatus required: potentiometer, power supply 1.018 volt, 2 volt and 6 volt, galvanometer, ammeter, voltmeter, rheostat, standard resistant, high resistance and jockey. Description: a potentiometer consists of a uniform wire of 10 meter long stretched on a long wooden board in segments of 1 meter each. Second, a moving contact known as jockey slides on the wooden frame and it is used to make contact on any wire at any point. Third, a meter scale is fixed on a raised wooden strip along one side of a plank and it is used for measuring this balancing length on the potentiometer wire.
This is the circuit diagram for determination of balancing length L0 for the standard cell. A 2-volt battery and key are connected in series with the potentiometer wire, and this is the primary circuit. A standard cell 1.018 volt, a galvanometer G and high resistance HR are connected to the point A and the jockey J. From this we observe the standard EMF, standard cell EMF 1.018 volt, the balancing length for the standard cell L0.
The connections are made as shown here. From 2 volts battery positive, a wire is connected to the terminal A of the potentiometer. From the negative of the 2 volts battery, a wire is connected to the point B. From 1.018 volt positive, a wire is connected to the point A. From the negative of 1.018 volt, a wire is connected to the galvanometer. The other end of the galvanometer is connected to the high resistance and to the jockey. Jockey is placed in the first wire to check for the deflection. It is in the left hand side. Now you can press the jockey again the second wire. Now the deflection is also in the left hand side. Now the jockey is placed in the third wire. Still the deflection is on the left hand side. Now again the jockey is pressed on the fourth wire. Still the deflection is on the left hand side. Again the jockey is pressed in the next wire. Still the deflection is on the left hand side. Now you can press the jockey, the next wire. Now you are getting the deflection where it shows 0 on the galvanometer. That means this is a null deflection point. Now we can take the reading by measuring the distance. So this null deflection comes in the 6th wire. So now we have to measure the distance by making use of another scale. So it is 514.7 centimeter. This is a reading corresponding to L0, that is the balancing length for the standard cell.
This is the circuit diagram for ammeter calibration. A 6-volt battery, a standard resistance, a rheostat and a key are connected as shown in the circuit. The ammeter is connected in series with the standard resistance. Here we observe the standard resistance R is equal to 1 ohm. Procedure: the rheostat is adjusted so that the ammeter reads 0.2 ampere. The jockey is pressed near the ends A and B of the potentiometer wire. The deflection must be in opposite direction. The balancing length L1, for which the galvanometer shows null deflection, is measured. The experiment is repeated by adjusting the rheostat so that ammeter reads 0.4, 0.6, 0.8 and 1 amperes. The corresponding balancing lengths are observed. If I is the ammeter reading, then the actual current flowing through the ammeter I prime is calculated using the formula I prime is equal to 1.018 L1 whole divided by R into L0 amperes. The error I prime minus I ampere is calculated and tabulated. This is the tabulation for ammeter calibration.
This is the power supply, and this is the positive terminal of the 2-volt power supply. This is the negative terminal of the 2-volt power supply. This is the positive terminal of 6-volt power supply. This is the negative terminal of the 6-volt power supply. Positive terminal of the 2-volt power supply is connected to the end A. Negative terminal of the 2-volt power supply is connected to the end B of the potentiometer. Then the positive terminal of 6-volt power supply is connected to the standard resistance, and the other end of the standard resistance is connected to the ammeter. And the ammeter is connected to the bottom terminal of rheostat. The top terminal of the rheostat is connected to the negative terminal of 6-volt power supply. Also, as per the circuit, the standard resistance one terminal is connected to the end A of the potentiometer. The other terminal of the standard resistance is connected to the galvanometer, and the galvanometer is connected to high resistance. High resistance is connected to jockey. To start the experiment, the power supply is switched on. Then, to check the functioning of the circuit, we need to operate the rheostat so that the ammeter pointer moves and shows the respective readings on the ammeter. Also, the jockey is pressed on the first wire near the end A and the last wire near the end B, which gives the opposite side deflection in the galvanometer. And now we understand that the circuit given is correct. Now the rheostat is adjusted so that the pointer of the ammeter reads 0.2 amps. It is pressed on the first wire, which gives the deflection in the galvanometer on left side, and the second wire, which gives the deflection on the right side. And we need to press different points on the first wire, and we have to find out the point which gives the null deflection, that is zero deflection. We observe that the distance 73.9 centimeter on the first wire is the balancing length for the ammeter reading 0.2 ampere, and this is taken as L1. By adjusting the rheostat and setting the ammeter pointer at 0.4 ampere, 0.6 ampere, 0.8 ampere and 1 ampere. At every step, we need to find out the balancing length L1 as in the previous case. And we need to tabulate all the balancing length values on the table. The actual current passing through the circuit I prime is calculated using the formula 1.018 into L1 whole divided by R into L0. And error value I prime minus I has to be calculated.
Next, the circuit diagram for voltmeter calibration. The primary circuit remains the same. The secondary circuit can be made as given in the circuit diagram. A 6 volts battery, a standard resistance, a rheostat and a key are connected in series, and the voltmeter is connected parallel to the standard resistance. Procedure: the rheostat is adjusted so as the voltmeter reads 0.2 volts. The jockey is pressed near the ends A and B of the potentiometer wire. The deflection must be in opposite direction. The balancing length L1 is noted. The actual voltage V prime across standard resistance R is determined using the formula V prime equals 1.018 into L1 divided by L0 volt. The error V prime minus V volt is calculated. The experiment is repeated by adjusting the rheostat so that the voltmeter reads 0.4, 0.6, 0.8 and 1 volt. The corresponding balancing lengths L1 are found and tabulated as given in the tabulation. The error V prime minus V volt in each case is calculated.
By the similar way, this is the circuit diagram for calibration of voltmeter. For that, instead of ammeter, the voltmeter is connected in parallel with the standard resistance. And the rheostat is adjusted so that the pointer of the voltmeter reads 0.2 volts. And we need to find out the balancing length. For that, the jack key is pressed on the first wire and the next wire, which gives the opposite side deflection. And we need to find out the balancing point, which gives the null deflection. This is the balancing point which gives the null deflection, and this is on the second wire. So therefore, after completion of the 100 centimeter on the first wire and 11.7 on the second wire, so totally 111.7 centimeter is the balancing length L1 for this particular volt, that is 0.2 volt. Similarly, the rheostat is adjusted so that the pointer reads 0.4 volt, 0.6 volt and 0.8 volt and 1 volt. At every stage, we need to find out the balancing length L1 separately by the same way. And the balancing length L1 are tabulated. The actual voltage dropped across the standard resistance is calculated as V prime is equal to 1.018 into L1 by L0. Also, the error V prime minus V is calculated.
Error graphs. We need to plot the error graphs for ammeter and voltmeter. The first graph is drawn with the ammeter reading I along x-axis and error I prime minus I along y-axis. The second graph is drawn with the voltmeter reading V along x-axis and the error V prime minus V along y-axis. The error values are pointed in the graph and the vertical lines are drawn from the point of error to the x-axis. There may be positive error and negative error. Result: the given ammeter and voltmeter are calibrated and the error graphs have been drawn. Thank you all.